looking at the back of the solar panels, and this is the largest array, building-mounted array in Canada. And what you'll notice here is you can see the connections for all, that eventually go into the building. So this is where the power connects, goes into the building. And you'll see that the roof here is one type. On another part of the building, it's a slightly different type of roof. It's more reflective, doesn't absorb the heat the way asphalt roofs will. And so it reduces what they call the heat island effect of a building. I know when I grew up in Charlottetown, I always thought the streets ran north-south. They don't. They're off by 45 degrees, which is why there is an angle on the building, which forced the angle, or was to provide the angle for the solar panels, as well as it provided better lighting and better lighting control on the floors below here.
21 kVA. And that's on a dull day. It's done through the irradiance. And that's just through the major.
We've got the smaller ones, which are also producing. So these are the smaller arrays that are on the windows. So these solar panels they're a dual purpose. One is they shade the south side of the building, and the other is they produce each section at each floor produces about 3 to 4 kilowatts through a program called Fat Spaniel, and that's monitoring the energy provided by the solar panels on a real-time basis. So you can see that as of when the building opened, we've avoided using 127,000 kilograms of CO2 or generating. So and you can almost tell when are the sunny days and non-sunny days. So
and presumably the fact that this is something that people see on their way out of the office is a sort of self-reinforcing message about the systems involved.
Systems. And this is available, anybody can see this on the web if they want to as well. Green roof.
And so what is a green roof made out of?
Well, in this case, it is a medium. You can see where the white roofing membrane is, and I'm guessing that's about a 4-inch thick medium of growing material with a gravel in it, and it's plants that are plugs of plants that are planted and will grow, and it does a couple of things. One, it provides additional insulation to the roof because now you've got 4 inches. It holds rainwater on the roof, so you're reducing the amount of rainwater that you're putting back into the system, and it obviously it looks better, it keeps the building cooler. The design of the building was around a central atrium. The idea was to provide as much daylight and views for the workers in the building as possible, and also to provide a mechanism for the air supply, which is a displacement ventilation system. So we supply air at the floor level, and we exhaust air here at the atrium just behind me. And if we open the windows around the atrium, we can get natural ventilation and not even have to run the air handling system. So the people working in the building want a steady environmental footprint. They want sort of a basic temperature, atmosphere level, certain level of lighting, and a certain level of heating and cooling. So how we provide it is when the trick comes in to save energy. In this case, we have a concrete floor slab, and embedded in the floor slab are heating and cooling pipes. Okay. So what we're doing is we're using the thermal mass of the building to supply the heating and cooling. And by doing that, and by monitoring the weather conditions, it reduces the amount of actual energy being used in the building. Now that comes with some issues, because you then have to predict the weather patterns in order to be able, because the heat doesn't flow instantly. It takes 6 to 8 hours for the building to warm up or cool down. So you have to know what the weather's going to be tomorrow in order to be able to predict the conditions inside the building.
It's like heating up the radiator in your house, really, in anticipation of what the weather condition is going to be.
Exactly. If you had the old cast iron radiators, it takes a little while for them to come up to temperature.
And I guess it also takes a while for them to cool down as well. Yeah.
So we have to be careful of those kinds of swings, and the building management system is supposed to be designed to work towards monitoring that. With the underfloor air system, that air is being supplied at about 64 degrees Fahrenheit. So it does provide some natural cooling, and it provides it to the individual working in the floor space.
So people have vents at their
People
at their
have
feet,
vents
is that, oh, that's
very
what that is
similar
there.
to one right there.
Okay.
And those vents are adjustable, so you can adjust the amount of air coming out to your own particular liking.
Right.
And because it's an access floor system, that can also be picked up and moved around.
Awesome.
But the lighting system is also one of the first of its kind, really in North America, because it's on occupancy sensors and it's on daylight sensors. So as the daylight gets brighter, the lights will dim and automatically.
Okay.
And also, I believe that this time of night, which is later on in the afternoon, and as people are leaving the building, once they leave, the occupancy sensors will sense no movement and lights will shut down. So the building is saving an awful lot of energy by doing that. We did try to push the envelope a little further. We were going to try to have a system where the lights, if you came in at night to work, when you came in and used your pass card to get in the building, it would identify where you were going and it would automatically turn a path of light on to your desk.
Yes.
But the system has the capability of doing that, but that's probably going a little too far at this point. People aren't quite ready for it yet.
Yes.
We only have 2 elevators in the building. We have about 500, 600 people in the building. And by normal standards, that's too few elevators. But we did put in this central staircase. We're in a sustainable world. We want people to use the stair more. Obviously, we have to have elevators to provide services. But we found, and I think the building operators have found, that more people are using the stairs because the elevators are slow.
Yeah.
So it's good for
Yeah.
everybody.
Sure.
It works. Because it's a displacement ventilation and we supply air, so on the far side of a space we'll supply air. That air has to get back to the atrium. So there has to be a path for the air to travel.
Right.
And in traditional buildings where people want to have enclosed offices, that starts to be a problem. It's a problem for acoustics and for privacy. And so we've dealt with that in a few different ways with different levels of success. But it is one of the difficulties with displacement ventilation. With this building, we had a very integrated design team with Public Works. We worked really well with them. And the concepts were all developed over a period of time with owners' representatives. But what happens, because the design and development process takes so long, the contractor is not part of that team. The contractor gets hired based on the lowest bid and not on being an integrated team player. And also, we didn't get a chance to help the users understand the building and what the building is all about and the benefits and way to live and work in the building. So that's an area where I think architects have to start getting more involved. Is if we're spending, as I was telling you on the way up here, about 8 years in developing and building a building, we should spend another couple of months to help people learn how to use the building that we've evolved through this process. Unfortunately, you get people in here that come in and they come in with a culture from where they were and they have no idea what to expect.
Yes.
So we still have a way to go to finish the process. So the selection of the site is in downtown Charlottetown. It's an urban location, and it was becoming somewhat derelict. It's the site of an old service station. There used to be a biker club here. There was a fuel oil distribution center here. And previous to that, there was not a foundry, but a tanning, not a tanning salon, but a place where they tanned hides.
Yes.
And the federal government purchased the land very deliberately to replace or renew the brownfield site. And I think which is a wonderful thing to do because it gave the site back to the city in many ways. But it did cost a lot of money. There was a lot of contamination in the site from hydrocarbons and from lead and arsenic and every other known metal and contaminant to man, I think, was here. And part of that came from the old tanning operation in the tannery. The site across the street from here also had contamination from hydrocarbons, dry cleaning fluids, and all of the things you find in a downtown location. So what the federal government did in this building, the provincial government did in the building across the street, is clean those up. And that's a major legacy back to the community. And I think it speaks volumes for what the federal government was trying to do here, that it's been as successful as it has been. And part of that is where we're sitting right now is a small pocket park, a little urban park off one of the main streets. And it provided an opportunity for some green space, which again is giving back to the community as well as to the tenants in the building. Well, our firm, as you know, is made up with 4 partners, or at the time we did this building. And we competed in this building as a sustainable building. That was what the federal government were looking for. So we entered a national competition to do the design for the building. And with my partner's experience in the ARC and previous sustainable building projects, and our association with a firm called HOK, which is very well known for their sustainable designs, we competed very hard for this, and certainly it is a high point of my personal career. I ended up representing our firm on the project most of the last 6 or 7 years. And it followed directly on the heels of doing another very similar project across the street. It didn't have as much energy efficiency wasn't seen as being the high point of that particular building, but in actual fact, it also is more energy efficient than one would have suspected. So, yeah, this is a very crucial part of what BGHJ Architects is all about, and for me personally, it certainly is a high point. Part of the mandate we were given, or we were asked to provide, there were 3 key factors that the federal government wanted us to provide. One was sustainability, because even at that stage, the federal government was getting very concerned about where we were going with energy use and how we were going to build buildings in the future. They wanted us to look very closely at connectivity and how the building was connected technology-wise, as well as connected within the city. So where it's located on the central street in the city of Charlottetown and so on. And they wanted us to look very carefully at the workplace solution. So the individual worker was having the ability to control their environment and could be as comfortable in that environment as possible. So that was the challenge they gave us, and they didn't know how we would respond. They didn't know how to respond themselves. And I think what we were able to give them, and like I say, I have to give a lot of credit to HOK, but we were able to give them a solution to all of those issues. And we were able to do it in a building that met their budget and pushed the requirements as far as possible. And during the course of the design, we had a catchphrase that we were working with, and one was that they wanted to be leading edge, but they didn't want to be bleeding edge. And we forced that issue on a number of occasions. Sometimes we had to pull back, but our engineers, the design team in general, worked really, really hard to try to take those concepts that provide real energy efficiency and to build them into a modern building. And a lot of that comes back, as you were saying, to the thermal mass of the building. It's a very old concept. It's used in adobe buildings, it's used in brick buildings, hundreds of years old, thousands of years old. Well, this is bringing it back to the modern future, and this is where buildings will go in the future to be that much more energy efficient. It's rethinking the process and going back to first principles and trying to use systems that are easily maintained, that are going to provide the energy efficiency and are just simple. They don't have to be complex. The technology will deal with the complexity. The thought process has to be kept fairly simple, and I think that's the key.